first for the 709 and the 909 series, 2.5 through 10. This is a 3-inch body, happens to be a bronze bodied option. Standard was cast iron fused epoxy coated, but they did make a 2.5 and 3 as an option in bronze. As I showed you, the test cocks come up on the cover. This being the first check, this would be our number 3 test cock. Our number 2 test cock would be on the body on this side. This is where that relief valve sensing line would be attached that I was showing you in the picture. And I wanted to show you the fitting for that relief valve sensing line because it's come in several different fittings over the years. The currently produced unit has the thread that goes into the body, and it has a copper tubing that is soldered to it. So what happens is I insert this into the body like this, and looking from the side view, you'd see here that if this plugged up on the threads here, it would go along this body. So the body actually extended into the water passageway of the valve. So in this way, when the cast iron body would plug up on those threads, this tubing would extend past it and it wouldn't plug up the sensing line. So this is the currently produced fitting that they use, and it's helped eliminate a lot of the plugged relief valve sensing lines. This original fitting was made out of aluminum, and the aluminum ones would rust rather rapidly in the water passageway, and those hopefully have all been changed by now. The second generation of them did not have this copper tubing soldered on the outside, and it was just a fitting right here that threaded into the body. And when it threaded in, it would plug up just like a test cock would on a standard unit. Then they finally went to this unit where they put the little tubing on the inside that came all the way out and made sure that way that if the test cock did plug up, it would not, I mean, like a test cock would plug up, the relief valve sensing line would not plug up. So you may find one of any of those three, the old aluminum one, the brass fitting without the nipple, and like this one, the one with the nipple soldered onto it. This is the current one, and this is the best one because it makes sure that you don't have problems with the relief valve sensing line plugging up on the high pressure side. Anyway, back to the check body. Cover bolts on the top. Once we release the bolts, check cover comes off. Cover is sealed by an O-ring. There is a check assembly which comes out in one piece. The check assembly is, the spring is contained when you remove the cover from the valve. And the check body, when you look inside, there is the check seat in there. It is replaceable. On the 2.5 and 3-inch design, the check seat is what's called a bayonet design. In other words, you see that little knob right there and the corresponding knob on that side. Notice I'll rotate that seat 90 degrees like that, and now the seat will come out of the body. In other words, it's held in by those two lugs that you see, one right here and the second one right there. So it goes into the body, rotates 90 degrees, and is held in by those lugs in the body. That's only on the 2.5 and 3-inch. It's guided through the center, and that's where this check assembly will sit just like this inside the body. The check seat is sealed by an O-ring, which sits right there in place. Check assembly comes out. Again, to remove the check disc from the disc holder, one nut, disc retainer, check disc, average repair, replace just the check disc, disc retainer, and our retainer nut. Now, I said that's 2.5 and 3-inch because the 4 and 10-inch is just a little bit different that I want to show you. And here's a 4-inch version of that check assembly. You'll notice that it's very similar. It has the large nut that holds the disc in the disc holder. When we get to the 6-inch, these disc retainer plates are held on by Allen wrench screws. Again, the spring does not have to be removed, released for the average repair. But what's different is the seat. Notice the 2.5 and 3-inch had those lugs that I showed you, and that's what holds it into the body. The 4 through 10-inch do not have these lugs. And the 4 through 10-inch, if you look at the side view of this seat, has an extra channel right there that does not appear on the 2.5 and 3-inch. That's because the 4 through 10-inch seat are held in by two retainer clips. And the clips go in from the top, insert down just like this, down from the top like this, screws into like here. And the two check wires hold the seat in just like that. And that's how the seats on the 4 through 10-inch are held into the 709 and 909 check bodies. 2.5 and 3-inch use that bayonet design like you see here with the two little lugs. The 4 through 10-inch will have two clips on the bottom. And to remove the seats, you grab one of the clips, pull one out, grab the second clip, pull it out, and then the seat will come out in one piece. And there's the seat O-ring that you see right there. So 2.5 and 3-inch, that bayonet quarter turn or eighth turn design. The 4 through 10-inch, use the clips, remove the clips, and the seat will come out just like that. Now, as I said, the average repair, you're just going to take this disc off and change it. You do not have to release the spring tension for the average repair. And if you look in the Watts repair manual, it'll say to when you repair this assembly that you do not disassemble the spring. Well, unfortunately, whenever we have seen this before, designed before, where there's a stem going through the center, we know there's got to be an O-ring in the center of that stem. We have a stainless steel stem passing through a brass disc holder. And if you read the directions from Watts, what it will say is do not disassemble stem. So in the paperwork with the repair kit, what it says is, warning, spring assembly is factory assembled. Do not disassemble. Notice here, where that letter A is showing you the part of that stem, on the bottom of this middle of the stem right there is that O-ring in the center of that stem. Well, it makes sense because that stainless steel stem travels through the center of that check disc holder all the way up to the spring retainer. But Watts is telling us we cannot disassemble that. We know that the average repair only requires us to change the disc. We know the average repair doesn't require the seat to be removed. We know the average repair doesn't require that stem O-ring. But what happens if it does? How do we change that stem O-ring? And more importantly, why does Watts not want to disassemble that assembly? Well, let's take a look and see how it is assembled. This check stem is not a unique design. We've seen about 5 manufacturers that make this exact same design. What is unique is the way that Watts does put the seal on the spring retainer. Again, you do not have to release the spring for the average repair, but all the other manufacturers either use a bolt or a nut here, depending which version they have. Wilkins used the bolt, BAVCO used a nut also, and anyway, the different manufacturers use different types of fasteners at this point. Watts uses what's called an E-clip. And an E-clip is a small little metallic piece that holds that spring retainer, just like a fastener would. And when it's properly applied, it is extremely strong, actually more stronger than a fastener would be in that particular location. But believe it or not, this E-clip can be improperly applied. And because of that concern, Watts makes it, like it said in those directions, do not disassemble, because they're afraid you're going to put this E-clip on incorrectly. How can you put an E-clip on incorrectly? Well, let me show you how an E-clip works. The snap ring may look like a relatively inexpensive type of piece of equipment compared to a bolt or a nut or anything like that, but it's an extremely strong piece of material when properly used. Snap ring may appear to be a relatively inexpensive piece of fastener compared to a bolt or a washer, but it's an extremely strong piece of material. In other words, when properly inserted into that little groove with that half in and half out like this, that has an extremely strong and capable ability to hold the load of the spring and anything underneath it like that. But as I said, it is important that it's installed correctly. Here's something most people don't know, is that snap rings are directional. They only go one way for proper load. How a snap ring is made is that a flat piece of steel is laid out, and this die kicks in from the top like that and stamps out what looks like an E-clip. And as it stamps it out, you'll notice that there is a rounded side and there is a sharp side. As the die goes into it, it's going to round as it cuts down, and when it hits the bottom and cuts through, that very sharp edge appears down here. This is what's important, and this is what gives that load, because if this is sitting in the retainer and the force is pushing against the sharp side, that is an extremely strong force and will hold it very, very well. If you put it upside down and the force is pushing against the rounded side, you can see that the force has it so that it's halfway out of the retainer already. And if it's like that, the retainer, what will happen is the spring will become apart. The way you can tell is you go to take the check cover off, and as you pull the check cover off, instead of the spring being contained, the spring is loose and the cover has all the spring tension underneath, and that's because the retainer clip pushed out of the holder. So Watts' way of making sure everybody does it correctly says do not disassemble spring assembly and buy the whole assembly. Well, relatively inexpensive spring clip can be bought if you have to replace the spring, but it's critical that you put the retainer clip back in the right way. So if you have to replace that spring clip, that's what that little part here is showing you, that clip right there. And make sure it's put in the correct way so the sharp edge is pushing with the force load, not the rounded side, because if it's the rounded side, it'll push and come right off. Okay. So normal repair, we don't have to worry about that though. Just take off the nut or the Allen head screws on the larger 6 through 10 inch, change our check disc. If it's the 2.5 and 3 inch, as I said, it's the seat with the bayonet clips. If it's the 4 through 10 inch, it's the seat with the 2 spring clip wires that we discussed already. So let's go ahead and put this check back together, put our O-ring back on the seat, have our seat back into the body. The seat does not have to be removed for the average repair, but if it does have to be removed, that's how it's removed. Check stem assembly, one disc here. My stainless stem guides through the center of the seat. Also guides on the back side through the spring retainer where that clip is, as I showed you. So go ahead and insert back into the body. Back in place, just like that. Check cover O-ring on top. Cover bolts. And that's the check mechanisms out of the 709 and the check mechanisms off the 909 flange 2.5 through 10 inch. So here's the relief valve bodies away from the check body, but just different, mounted between the check bodies, as I said earlier. Here's the flange where it sits, and it would be wedged between the first and second check bodies, just like that. As I showed you in that picture is that test cock, that 1/5 test cock that causes problems. Here's where it would sit off the top here, and that high pressure sensing line comes through the bottom of the cover, comes up through the top of the cover, and that's where my air bleed is here. That's also what puts the high pressure sensing line on the top of my relief valve stem. Remember we talked about the hose. It would be connected like this, going to that port on the body where we made sure that we don't have that plugged into the check body. You're going to find either a cast iron epoxy coated body, which will be the blue epoxy is what Watts uses, or you're going to find the bronze bodies. 2.5, 3, 4, and 6 inch had bronze, and 4, 6, 8, and 10 inch had cast iron. Again, 4 and 6 were the ones where you might find a bronze body or a cast iron body, so be very careful because the repair parts were slightly different. The rubber kits were the same, but the rubber parts were different. Another thing I want to show you on the body before we take it apart is that discharge drain that we talked about. Notice on the small 909s, they have that 2 discharge out of the bottom. And same air in, water out design that we talked about with the smaller version. On the bottom of the larger units, the cast irons and the 4 through 10 inch, you're going to see this plug comes off, and it's what's called a spring button. And what the spring button is your relief valve spring. And it sits just like that. And the relief valve stem comes in from the top and rests on like this. So, as you can see, this whole stem, the whole stem is balanced on the top of that the spring. But the spring on the larger 4 through 10 is inserted from the bottom, just like this. The 2.5 and 3 inch, the spring is attached to the stem, so we don't have the spring button on the bottom. There is a plug on the bottom, and that has to do with cleaning it out and if we have to repair that stem also. So the 4 through 10 are going to have the spring button. The stem is going to rest on the spring from the top. The 2.5 and 3 inch, like this one, the spring is going to sit on the stem and also going through the top. So let's go ahead and take these two bodies apart and take a look at them. So here's the 2.5 and 3 inch 909 relief body out of the checks. You can see it mounts between the checks right like this. Relief valve sensing line comes through here from the body. Up here where that test cock is, the air bleed that people confuse as a test cock. Does not have to remove the body for the average repair. You would leave this between the checks for the average repair, but I'm going to have it loose like this just to show you what it looks like. Go ahead and remove our relief valve cover bolts. There will not be spring tension underneath on the 2.5 and 3 inch. There will be a small movement of the cover, as you see, just like that. Cover comes off first, relief valve diaphragm, and it exposes our diaphragm retainer. By grabbing the stem in one piece, it'll come out just like this. Relief valve seat stays inside the body, can be unscrewed as there's 2 little legs on that side. Take a little driving rod, can unscrew if you have to change the relief valve seat. Average repair, it doesn't have to. There's a plug underneath which doesn't have to be replaced or removed for the average repair unless this spring assembly here came apart. Sometimes, unfortunately, when you pull this relief valve stem out, the spring is gone or the clip on the end here because they use a very small E-clip, as you can see right there, that holds that relief valve stem together. And we've already talked about the concerns for an E-clip, and if the E-clip's put on incorrectly, that spring will come apart. So hopefully the stem will be just like this with the spring attached, but if you take it out and the spring's not, you're going to have to turn this plug to get the pieces from there out of the body. Disassemble of the relief valve stem. This piece here, if you look on the back side, is my relief valve disc. In other words, it's sitting in the body like this. My diaphragm comes to top, high pressure here, low pressure sensing brings the pressure underneath. The diaphragm moves up and down as we've discussed many times, moving the stem. But on the top of here is my relief valve disc though, so it unscrews off the top of the stem. The relief valve disc is molded into the brass disc holder like we've talked about in most of the Watts designs. There is a very small stem O-ring and my relief valve disc guide. Reassemble is going to be just the reverse. I'm not left-handed. Go ahead and tighten that up. On this side of the stem, the only thing we're going to change is this O-ring right here. O-ring has to be properly lubricated like we've mentioned many times. And back on. Don't have to release the spring tension for the average repair, but if you do, there's this O-ring in the center of the piston right there that you have to change. Now, the 909 series, it's very important that we properly lubricate this going back together. Same air in, water out design that we talked about earlier, but because of the motion of the stem, in other words, all of our movement from the diaphragm pushes down like this, and it compresses the spring on the bottom. So you want to make sure that the spring is sitting in its retainer, properly compressing here, and making sure that the O-ring moves through its bore. If it's pushed sideways in any way, you see it's going to bind up that stem. So we want to make sure that the O-ring is lubricated, then put it onto here, lubricate the stem, and then lubricate the bore of the seat right here. As we go to put it back in, it's a relatively blind assembly. As you can see, we're pushing the stem in here, and I can't see what happens when I'm pushing here. What have I got right here? Four-fingered guide, right? If I'm just sitting here pushing in and not paying attention as I push the stem in, and I get to that point, what did I just do? Obviously, I just drove that guide right into the seat. So I want to be very careful as I'm pushing it in that I push it in slowly, not very aggressively, until I get it to this point, and then get the guides past the seat. Once I have the guide past the seat, I'll stroke my stem up and down, making sure it works properly like I want to do on all relief valves. Relief valve diaphragm, relief valve cover. And that's going to be the 2.5 and 3-inch 909 relief body. Here's what the larger 909 relief body looks like away from the check assemblies. Our sensing line, again, that tubing comes in from our test cock up through here, which puts our high pressure sensing line onto the top of our relief valve diaphragm. This test cock up here is an air bleed, not a test bleed, not a test cock attached through here. Going to give you a feeling what it looks like inside, like that. Again, it does not have to be removed from the check body for the average repair, but I'm just trying to show you what the relief body looks like by itself. Anyway, the relief valve sensing line does not have to be disconnected for the average repair. Removing my relief valve cover bolts. Cover will come off from the top. On the larger cover, there's two little wrench holders like this, little handles, so that I can grab the cover easily, pulling it off. Relief valve diaphragm comes out next. Stem assembly, just like on the 2.5 through 3-inch, we'll pull out from the top. Just like that. And relief valve seat, which does not have to be replaced for the average repair, but you can see I've got this one loose, unscrews, and is sealed by an O-ring. Now, what that looks like from the top is that stem, with the diaphragm on top, is sitting right here. We already talked about what's on the bottom here is that spring button. The spring button does not have to be removed for the average repair, but I want to show you what it looks like outside the body. So here's what it's going to look like. Just like that. And our diaphragm on top there. So that's what the stem looks like. Spring button stays in the bottom, which is our relief valve spring. The stem pushes in from the top. And our relief valve seat, which you saw right there, seals on our relief valve disc right here. Okay. So if this is where my diaphragm sits on the top, and this is my relief valve disc right here, what are these two things? Well, remember that air in, water out design? Well, with the smaller units, 3/4 and 1-inch, we achieved that with the body passageways and one O-ring. But because of the size of the body and the distance between the air in, water out design, we actually had to have two different seals. There is a wiper seal and there is an O-ring. In other words, these two pieces of rubber are different. This one is actually a flat disc, and this is an O-ring design. An O-ring. So changing it, we have to lubricate it like an O-ring. The wiper seal, we have to change that. It does not have to be lubricated like the O-ring does. Spring button does not have to be replaced for the average repair, but you can see how it sits there from the bottom, and the bottom of my relief valve stem sits on top of it. This is the spring that's utilized in the 4 and 6 inch 909. This is the stem that's used in the 8 through 10 inch 909. And there's the stem that's used in the 2.5 through 3 inch 909. 2.5 and 3, the spring is contained to the stem, as we already talked about. The 4 through 6 and 8 through 10 I wanted to show you here. The reason I wanted to show you these two stems because they all have a spring button, different type depending on the body, whether the body be bronze or the body be cast iron like that. Rebuilding them is the same process. This diaphragm retainer unscrews like this. Relief valve disc unscrews next. Underneath my relief valve disc will be my relief valve disc O-ring, which sits right there. Reassembly is just the reverse. The relief valve disc is molded into the brass disc holder. So I want to go ahead and tighten my relief valve disc, load that O-ring, then go ahead and tighten my diaphragm retainer second. Don't try to tighten them both at the same time. It's like a double nut. If you do that, you're going to have one bind. Pulling the wiper seal out here, comes out like this. O-ring comes out there. Change those parts, lubricate them properly, put them back together. Now, the reason I wanted to show you the two different stems, because as I said, there's a 909 and there's also a 909 M1. If you were fixing a model 909, this would fit 4 through 6 inch. This would fit 2.5 through 3, and this would fit 8 through 10. If this was a 909 M1, this is the same stem in sizes 4 through 10 inch. If you have a 10 inch 909 M1, it would have this stem in it. If you have a 10 inch 909, it would have this stem in it. So getting that M1 design, the M1 designation when we order parts is critical. Otherwise, you're going to have the wrong parts for the wrong stem on the assembly. Now, if for some reason you have to replace the spring button, spring brake, something like that, I want to show you inside the body here. Let's do it like this, right there. Notice that stainless steel sleeve right there. That actually threads in the body of the cast iron units. In the bronze body, that's actually machined into the brass body. That's where this O-ring and wiper seal, you're going to see the second sleeve up through the back there, and the first one right there, where these two seal as they move up and down in there. They usually do not have to be replaced, but if you do have, there you can see both of them now, if you do have to replace, if you do have to check them to make sure that they're not scarred or damaged, because obviously if it's scarred, it's not going to seal across that O-ring, and it's going to leak through the body. Does not have to be replaced for the average repair, and it's very rare that it does corrode because it is stainless steel. But it may happen sometimes, but you want to make sure you know that's where you're going to be inspecting it to make sure that where these two wiper seal and O-rings sit actually belong. So with the stem out, it's the best time to put your spring button back in, because now you're not trying to line up the center of that stem. I've got my rebuilt stem ready to go back into my body. So let's do it this way. Same thing as with the 2.5 and 3 inch. I don't want to push too hard because this guide right here, as I'm pushing down, can nick or damage that seat. So I'm going to put it in place, kind of wiggle it around so that it goes in without hitting my seat like that. I don't want to hit it. If I hit it hard like that, I have a good chance of damaging it. Next, I got to get the wiper seal through the center of the seat. Again, a little bit careful as you get it pushed into the body, just like that. And now I go ahead and line it up with a guide going through the seat. Once I have it lined up, stroke the relief valve stem, make sure it moves easily, shouldn't be any grinding action or anything like that. Line up my diaphragm, which has a notch for my high pressure sensing line, just like this. Relief valve cover bolts. And that's the larger 909 4 through 10 inch relief valve body. So we've seen the 3/4 through 2 inch bronze body unit. Now we've seen the flanged units in the 709, which is the double check assembly, 709 DCDA, which is double check detector assembly, 909 and 909 RPDA, reduced pressure detector assembly.